So we were assigned units 5 and 6 for our project, which is similar and congruent triangles. We're going to start with unit 5, similar triangles. The first rule is that if two polygons are similar, then their corresponding angles must be congruent. The second rule is that if two polygons are similar, then their corresponding sides must be proportional. Now, when you write an extended proportion for similar triangles, you have to line up the corresponding sides of both triangles and put them into a fraction. This will help you find the scale factor because whichever fraction from the extended proportion has the numerator and denominator both as numbers instead of one having a variable, then you know that it is your scale factor. We use the scale factor to help us find missing sides of a triangle. On to similarity statements. When writing a similarity statement, for example, triangle XYZ is congruent to triangle BAC, you always have to keep the corresponding letters together. Since X is the first letter in the first triangle and B is the first letter in the second triangle, X and B must always line up along with Y and A and Z and C. Moving on, to find all the measures of a triangle using a ratio is quite simple. Say the ratio is 4, 5, 6. All you have to do is set up an equation that equals to 180 because that's always the total measure of a triangle. For this ratio, it would look like 4x plus 5x plus 6x equals 180. After you combine the like terms and divide, x will end up equaling 12, but the problem isn't finished yet. Now you substitute in 12 for x, and then you will get 3 answers, and all 3 will be your answers. After ratios come roller coaster and boomerang. These methods are used when finding the value of a variable either inside or outside of a triangle. If you want to find the value of what's on the inside, you use roller coaster. What you do is you move along the base of the triangle until you see the 90-degree angle. When you see that, you go up inside of the triangle and capture the variable there, then go back down and along the rest of the base. So, you would go along the 9, up the 90-degree angle, capture the x, and go back along the rest of the base. Now, with the second method is boomerang. It's basically the same thing, but now you go all the way along the base, and then you go up the side to capture the variable, then back down the same side, but you stop once you see the 90-degree angle. Now, for this one, you go all the way along the base, up the side to capture the variable, and then you go back down, then stop once you see the 90-degree angle. You do with these two methods, you can set up proportions and solve for x. Now on to proofs. When proving a triangle is similar to another triangle, you will always end with a similarity statement. The statements for Unit 5 are angle, angle, AA similarity, side, 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 SSS similarity, and side, angle, side, SAS similarity. These can be determined when looking at the triangle and seeing which has 2 angles, 3 sides, or 2 angles and 2 sides and 1 angle. The proofs will change when we get into Unit 6. Now for Unit 6, we have triangle congruence in this unit, and one rule is corresponding sides and angles are congruent to make two triangles congruent. Included angles are important in this unit. An included angle is when an angle is already in between two sides of a triangle. This can change your congruency statement because if the angle is not included, then it is a failed SSA or an SAS. So you have to be very careful. Now in this unit, you can tell corresponding parts just by looking at a congruency statement. For example, triangle EDF is congruent to triangle WXY. This is just like the extended proportions in Unit 5, where corresponding letters line up with each other. This time, though, we're using lines and angles congruent to each other instead of fractions. For the proofs, you were told these would change before getting into Unit 6. The reason this changes is because of the similarity statements and CPCTC, which I will later explain. The similarity statements are now side, 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 SSS similarity, side, SAS similarity, angle, side, angle, ASA similarity, angle, angle, side, AAS similarity, and hypotenuse leg, which is HL. You have to be careful when using hypotenuse leg because it can only be used if the triangle was originally SSA, but it has to be a right triangle. If the triangle is SSA SSA but isn't a right triangle, then it is not HL. So when writing proofs, this must come to mind and you must be very careful. The difference between Unit 6's proofs and Unit 5's proofs is that now we're proving that angles are congruent. Saying this, there will always be an extra step in the proofs because of CPCTC. This stands for corresponding parts of congruent triangles are congruent. This is crucial when it comes to these proofs because it would not be complete without it. These were Units 5 and 6. Thank you for watching.